Okay, so today's lesson we're talking about some ratios, portions, or proportions and percents. So let's start with the first one, ratios. So ratios are very important. Something that we basically use daily in different areas. So understanding this will make your life a lot better. You'll make better decisions, especially, I don't know, in cooking or working, whatever you're doing. Ratios and proportions are an interesting topic. We're going to see why. So let's start with the ratio. So a ratio is basically two quantities that are related. Two quantities that are related. That means, let's say you have, let's say, one item. Let's say one item costs. Let me write it differently. Say one item let's say costs for example $3. Okay, so these two quantities are related, so they make what we call a ratio. So one item costs $3. If you want to buy more items, you're going to need more money. So if one of them changes, the other one has to change. So they are related. So they change, we say, proportionally. That means they have to change. If one changes, the other one has to change in a certain manner with a specific amount or ratio. So if one item costs $1, two items will of course cost how much?
$6.
That's right. Items will cost $2. I mean $6, and so on. So that's a ratio 1 to 3. We say 1 to 3. So the notations of ratio are various. There are various ways of expression ratios. So probably the one that makes most sense is this one, 1 to 3, like this. You can also write 1, the word 3. But the standard notation for ratio is a colon like this, 1, 2, 3, for example. They all mean the same thing, but this is the standard form or a notation for ratio. Say 1, 2, 3. You can also say sometimes we use that 1 by 3, or we can even express them as fractions, 1 over 3. So all these basically express what we call ratios. And when you know the ratio of something, that's basically like the formula or the basic formula that we can use to find other ratios based on this one. So 2 items cost 6, 3 items cost 9, and so on. So if you know one of the quantities, you can figure out the other one. We're going to see later how to put this into equations, first 2 equations, and find the missing quantity. Sometimes you're given 2 ratios like this. One of them is missing. For example, you have x here. You don't know this amount. We're going to see how to use equations to figure out this amount in case we didn't know it. Ratios could be basically anything. It could be items, money, people versus whatever, income, or something like that. Could be any related numbers or quantity. By the way, it doesn't always have to be 1 to 1, 1 to 2 quantities. It could be more. For example, 2 to 3 to 7. Okay, we have 3 quantities here related. For example, let's say you're cooking, so you need 2 eggs, I don't know, 3 spoons of butter, for example, and 7 teaspoons of maybe cream or oil, whatever. So this is, for example, the recipe for to make a cookie or a cake or whatever. So if you want to increase the quantities, all of them have to increase we say proportionally. If you increase this one has to increase in a certain or in a very well-calculated amount, not just random. Let's say if you double this, you have to double all of them. So that's what ratios are. So everything's proportional is related to one another. And if one increases, the other one or the other two have to increase. Again, we say proportionally. You can't increase one thing and not increase the other. For example, if you want to, you can just put 100 eggs here and use the same amounts here. It's going to be mostly X, 99% X, if not more. So you want to keep things balanced. As they say, add flour, add water, or something like that. So that's basically the concept of ratios. Let's see how to simplify ratios. So sometimes when you have a ratio of something, we can express it in an easier way, but in a simplified way. So simplifying ratios. Let's say you have, say, 15 to whatever, 45. Whatever this might be. Again, could be items to money, could be anything. Could be people to, I don't know, the number of, let's say, fruits they had or something like that. So this is a proportional, or this is a ratio of 15 to 45, which we can also express as 15 to 45. So this ratio is good, but we want to know, it does not make sense, especially if you have large numbers. We're going to see if we can simplify it into some simpler numbers that make more sense. If you say, well, 15 items for $45. Let's say you go to a store and 15 items of something, they cost $45. But you're not sure exactly how much one item costs, or 2 or 3. You're not trying to get 15, you just want to get 1, 2, or 3 items. So you want to simplify this ratio as much as possible so it makes more sense. For example, here 1 costs 3, and so on. So basically what we do is we simplify this. As we said before, we can express ratios as fractions. So you take your ratio, 15 to 45, 15 over 45, and you try to simplify it just like we did with the fractions. We simplified fractions before, we learned how to do that. If we simplify this, we're going to end up with a much easier to understand ratio. For example, these two, we can say 15. We can reduce this by 15. This is 15 times 1. This is 15 times what? What is 45? 15 times?
3.
3. That's right. Then we cancel these out. We end up with 1 over 3. So that makes more sense now. It's 1, 2, 3. It's the same ratio, by the way. It's the same ratio, just different numbers. So this one, just like with fractions, we always try to simplify them as much as possible. Same thing with the ratios. So this makes more sense. So it's easier to say 1 for $3. Now that you know your base ratio or the unit rate, it's what we call the unit rate. Once you know your unit rate, you know exactly how much you need, how much you're going to pay. So you're not trying to buy 15 of something. I don't know, 15 watermelons or whatever. So instead, you just want 1 or 2. So now that you have the base ratio, you say, oh, if I buy 1, it's $3. If I buy 2, that would cost me $6, and so on. So always simplify your ratios to the lowest terms, just like you do with your fractions. Okay, so the other thing we're going to talk about is proportions. So we mentioned proportions earlier as it was explained ratios. So let's see how to make up some proportions. Okay, so proportions. All right, so when you say, let's say 2, let's say 2 to whatever, to 4, or maybe 5. Okay, if 2 items, for example, cost $5, 4 items will cost, of course, what will this cost? 2 to 5?
10. 10.
4 to 10, that's right. So we say 2 to 5 is the same as 4 to 10. So basically this is a ratio, this is a ratio. Together, they make a proportion. Okay, so that's one ratio, one ratio. Together they make a proportion only and only if, of course, if the relationship is proportional. One way to verify whether 2 ratios are proportional is by cross multiplying them. So if you cross multiply 2 ratios, 2 times 10, is it equal to 5 times 4? So this is 20. It's also 20 here. So this is, in fact, these are equal. So you say these 2 ratios are in fact proportional. So the ratios, or the 2 ratios, are what we call proportional. Well, proportional. Okay, and that makes a proportion. If you cross multiply and the 2 multiplications are not equal, then you say they're not proportional, they're disproportional. By the way, you can say proportional or proportionate. You can also say proportionate. Same as here, you say proportionate like this. Okay, so proportional and proportionate mean the same thing. And the opposite is disproportional or disproportionate. Let's see an example. Let's say 5 to, I don't know, 3, 7 to 2. Are these 2 ratios proportional? That means, are they reliable? Let's say if you're cooking, so 5 to 3, whatever, is it the same as 7 to 2? Are you going to get a proportional recipe, or it's going to be out of proportion? Out of proportion, something is more than something. For example, you may end up with an excess of eggs or an excess of salt. You don't want to do that. Okay, so if you make it, for example, 1 cupcake, let's say you need 1, I don't know, tablespoon of sugar, just for example. If you're making more, you're gonna need more sugar, but you can't put 10 tablespoons of sugar in 1 cupcake. It's obviously it's not gonna be all right. It's gonna taste too sweet or too salty if you use the salt, whatever. So how do you find out again if these 2 ratios are proportional?
We multiply them.
Exactly, we cross multiply.
Cross multiply. Yes.
Right, so cross multiply. And we'll find out whether, just like we did earlier with equations, we cross multiply the fractions. So it's going to say 5 times 2. And we're going to say, is it equal to the other multiplication, 7 times 3? Okay, 7 times 3. So this is 10. This is 21. So what do you say about these ratios? So
They are disproportional.
That's right, exactly. So these ratios are disproportional. Ratios are disproportional. Disproportional or disproportionate. Okay, so again, when you increase one quantity for one thing, the other quantity or the other variable has to increase accordingly. Let's say, for example, you work out and you only work out one arm and you don't work out the other arm. So your arms will be disproportional. Okay, one of them will be bigger than the other or more muscular than the other. So we want to do the same thing, same number of movements or grips on both arms, so you can get something that's proportional, that's even and equal. Okay, so that's basically how we check whether a proportion is, whether two ratios are proportional. Simply cross-multiply them. If the multiplication is equal, it is proportional. Otherwise it's disproportional. Now, let's see how to find missing quantities. So sometimes, as I mentioned earlier, you will have missing quantities in a proportion. Let's say missing quantities. As we said earlier, let's say you want to buy, let's say 2 items cost $7. Say 2 items cost maybe $7. Let's say you want to buy 3 items. How much will that cost you? How much will 3 items cost if 2 items cost $7?
10.5.
10.5, okay, makes sense. Let's take a simpler example before we get to that. Let's say you want to buy, so 2 items, let's say you want to buy 4 items. Basically, we're doubling the quantity, right? 2 items cost 7, but you're doubling the quantity. Instead of 2, you're doubling this, we're getting 4. So you're going to double this as well, it will be 14.
40.
Both have to change proportionally. So if you multiply this by times 2, the other one should also be multiplied by 2. That way you get something that's proportional. So this is missing quantity or a proportion with usually a number here like X or something that we don't know. So now we're going to see how to actually, it's not always convenient, it's not always double or triple. It could be, for example, if it's 5 here, then what to multiply by exactly. So it's not always this convenient and easy. So we have a formula for this. We have a way to solve this by turning this into some first degree equations. So as we said before, if two ratios are proportional, that means their cross multiplication is equal. So when you're given like this, something like this with missing quantity, so the assumption is it is a proportion, you just have to find the missing quantity. So the question assumes that these are proportions, or these ratios are proportional. You just need to find the missing one. So you don't have to prove or you have to check if it's proportional, you just need to find the missing one. So same way, we're going to cross multiply this way and that way. So we're going to get 2 times x times x. It is equal to 4 times 7. As you can see, that's a very simple first degree equation. As we learned before, we learned how to solve these. So we're going to multiply first. That's 2x, 28. And then we just need to solve this. What do you do to solve this equation? One final step. This would be?
We find x, like we divide 28 by 2.
That's right, divide both sides by 2. So we end up with x is 14. That's the 14 we talked about earlier. We figured it out easily. But again, the numbers are not always this convenient to figure out. For example, if you have 1.7 here, and you have, I don't know, 3.8 here. So you don't know exactly what to multiply by. Might be a little tricky. That's why we need this. But if you turn this into cross multiplication, you end up with an equation, then you solve it. So that's the way to solve ratios, even when the numbers are inconvenient and they're not easily multiplied or divided like this example. So whenever you have a ratio with a missing quantity, just cross multiply and solve your equation. So to get the missing quantity. So the x here is this amount. So you don't have to guess it. You don't have to try numbers mentally. Just use ratios, proportions, and equations, and you can solve easily.
Professor, you can make one with the 1.3 or 2.2, whatever, so we can see exactly how it goes.
All right, let's do one example of that. So let's say,
Yeah.
for whatever reason, let's say 1 or let's say $1.5, whatever, for let's say for 2 items. And then you'd say you have, for some reason, you have 2, maybe 50 dollars, and you want to know, well, let's make it actually a little more interesting. Say for some reason you have $7.35, and you want to know how many items can you buy. Okay, or could be the other way around. The X could also be here. X could be anywhere, basically. The X could be here in any of these quantities, but the method is the same. So let's say 1 item, 1.5 for 2 items at the store, but you have this much money and you want to spend all that money buying this specific item, whatever it might be. So you're wondering, how many items can I buy with this thing? Okay, sometimes the numbers are kind of easy and convenient. You can figure that out quickly. Sometimes with the decimals and stuff, it might not be as easy. So, but always, you can always use cross multiplication and solving equations. So you can say 1.5 times x, that's 1.5x, and then 7.35 times 2. Times 2, 1.5 times x is 1.5x, and this will be 14, right? This will be 14 and 0.7, 0.7, I believe, that's right. You can always do your multiplication on the side. We'll learn how to do the multiplications of decimals earlier this semester. So this will be 14.7. What's left to do now to get the x by itself? Just like here.
Which is divide 14.7 by 1.5.
That's right. So we want it by itself. We want to cancel the 1.5, but we're going to divide it by itself. Also divide the other side by the same number. 1.5 cancel out, end up with x. Then you do the division. You do this division here. That's 14.7. So you need to do it on the side. Divide by 1.5. So this will be 9.8. Okay, what does 9 represent? The number of items. So you'll say, so how many items approximately that is? So that's 9 items. And you have a little bit of change left. Okay, with items, it has to be a whole. Okay, for example, you're buying, let's say, fruit. So you're gonna buy 9 fruits. You can't, I don't think you can split that fruit and take 80% of it or something. But when you look for a whole or an item, basically we just round it. We round this, so it's close to maybe 10 items. But if it's something that cannot be split, for example, a fruit or something, so you may say, so approximately 9 items. So if you have 7.35 in your pocket, you say, oh, I'm gonna buy at least 9 items. I'm gonna have some change left. Okay, it doesn't have to be accurate, but just get the closest whole number possible. Okay, that's basically how you figure out ratios. Sometimes it could be like this. Let's say X items. Sometimes the ratios are expressed as fractions. For example, X items over 5. Let's say we have 7 over 2. Okay, instead of having this like this, because we said earlier, we can write these as fractions. Another way of writing proportions is you can say 1.5 this over this is equal to 2 over x. It's the same thing. Just this is one is written as proportion as ratios. This one is written as fractions. We saw earlier that we can express ratios in different forms, including this form with the arrows or with the fractions. It doesn't matter the way you do it. By the way, you can do 1.5 over 2 equals 7.35 over x, or you can do it this way. This one over this one over this. As long as you do both in the same direction. Or you can do this one over this equals this over this. So these are the same, and if you cross multiply them, you get this. So if you don't have ratios, if you have two fractions like this, we learned how to solve this again before. We talked about it when we did the first degree equations. But now we need to figure out the x. What do you do again for this problem?
We make cross multiplication.
Exactly. And cross multiply. So we have x times 2 is 2x equals the other multiplication, 5 times 7, that's 35. Divided by 2, divided by 2. That's a decimal, right? It's approximately 17.5, right? That's x. Or you can just reduce the fraction. So you can say, so x is 35. Okay, it's 35 over 2 if you cancel the 2's. X is 35. Depending on what you're dealing with, if you're dealing with money, for example, you need some cents, you need some decimals. For example, here is $17.50. Or sometimes if you don't need decimals, you can just reduce the fraction. 35 over 2, try to reduce it if possible. If not, you leave it as a fraction. But that's basically how you deal with ratios. You can simplify them. So they're technically fractions. A ratio is just a fraction. Something to something is just that thing over that thing. So whatever we learn with fractions, also what we learn with equations applies to ratios and proportions. Does that make sense to everybody? Any questions at this point?
No questions.
Okay, Jessica, Lordine, Jennifer, you guys okay?
Yeah, I kind of get it. Yeah.
Mm-hmm. Jennifer, are you there? Okay, for some reason, Jennifer is not with us, but she's at least, her name is physically, I mean, she's not physically here, but let's see. So I'm gonna look at another thing now involving ratios. Make sure we cover every possible scenario. So word problems, okay? You're gonna run into a lot of word problems. They're not always written like this or like this, but you have to write them into ratios. Let's take an example of that. The word problems with missing quantities. Something like this. If let's say 3 items cost $17. How many can you buy? How many items with, let's say, $36? Okay, so that's a typical word problem that you may find that you need to solve. The method is exactly the same, regardless of what this is. Could be items and money, could be people and, I don't know, scores or points, could be cars and miles, it could be all different sorts of things. But you will have two variables, two things that vary. For example, we have items here, and we have the cost or the money. But in every case, it will turn into two ratios. Once you have these ratios written down, cross multiply and solve. So basically, we're going to translate this problem into two ratios. According to the problem, give me the first ratio, what to what? Give me the first ratio. It means quantity to a quantity.
First ratio is 3 to 17. to 17.
That's right. If 3 items cost 17, so to write it in a ratio, to write this in ratio notation, you're going to use one of these. I find one to make the most sense, 1, 2, 3 with an arrow, and later fractions. So first ratio according to the problem is this. So it's 3 to 17. Then the other ratio, to make sure you put the same quantities on the same side. So we're using this side for items. We're using this side for the cost or money. When you do your second ratio, it should also be items to dollars. If you reverse this one, you got to reverse the other one as well. Now, just gonna one of these is missing. What do we have?
X.
X.
X here.
X.
I don't know the number of items. It says right here how many. You can
So
add
we don't know the number.
how many items. Okay, so we don't know this. So we're gonna call this X. How many can you buy with $36? We do have the money, so we put the money under the money right here. So we don't know X items. That's what's missing. That's the important part. Write your ratios. Once you set up the ratios correctly, all you have to do now is just solve this. So just like we've been doing here. So you're gonna cross multiply this. If you wanna write them into fractions first, that's fine. You're gonna write 3 over X, 17 over 36. That's not a problem. 17 over 36. Or you can do 3 over 17 equals X over 36. Any way you do it, it will be fine because these two are proportional. Okay, these two ratios are proportional. As long as you do both in the same direction, it will always be proportional. Now, just cross multiply. You could have cross multiplied here, or you could do it after you turn it into fractions. So we're going to do, try to start with the X first, the X multiplication. Instead of doing this first, start with the X. We want the X to be on the left side, so X times 17. Okay, we did this. Now we're going to do the other multiplication. 3 times 36. So this is 17x. What's 3 times 36?
108.
108. That's 90 and 24 and 20. Yes, and 18. Okay, so then divide by 17 to cancel the 17, divided by 17. So x is, what is x? If you divide 108 by 17, what do you get?
6.3.
That's right, 6.35 approximately. So we're talking about items, so it's approximately, it's about 6 items. Okay, and you're gonna have some change left, so 6.35. Let's say if this was a piece of clothing, so you can say 6 and a piece of a dress or something, but rather take the whole number and you have some money, some change left from this 36. So all the word problems may differ in words and variables and whatever the words are that are being used for the problem, but remember it's the same concept, the same way. Turn that into ratio, then cross multiply. This works not only for this math class, but feel free to use this whenever you want to do anything like shop or cook or do whatever you need to do. You can always do this little math on the side, especially when you cook. So the number of people, they say, oh, 5, last time I cooked for 5 people, I spent, I don't know, $70. And this time I have 17 people coming over, how much money do I need? So you need to approximate, you need to know your estimates. Same thing with the food. They say, oh, last time I cooked a turkey that weighed, I don't know, 20 pounds, and there were 11 people at my house. But this time I'm having more people. They say 35 people. How many more turkeys do I need to get? So you can do the math. You can say 11, 1 turkey for 11 people. And this time I'm having 35 people over. How many turkeys do I approximately need? Okay, so you cross multiply your stuff and you see, do you need 1 turkey, 2, 2.5, whatever. And you could do the same thing with other ingredients also involved in that Thanksgiving feast, whatever you're cooking or making your pies or mashed potatoes and all that stuff. You can approximate all the other ingredients based on one ratio. So you need to have a base ratio or a base formula, or what we call the unit rate. From that unit rate, you can expand on it and estimate, not actually estimate, but you can get an accurate number of what exactly needed for different numbers here of people or numbers of turkeys and so on. So again, the ratios and proportions and percents are very useful in everyday life. So you can always take advantage of this and do our math. Okay, so that's for the word problems. Now, let's throw in another term, percents. So ratios, proportions, and percents. Percents is another very important concept to understand. It's useful almost everywhere, especially when you shop. Nowadays, you see, oh, this is 18% off or 10% off or whatever off. So hopefully by the end of this class, you will be able to do the math quickly in your head, at least in certain situations, and figure out exactly how much money you're going to save almost immediately just by looking at that percent discount on the window or on the label price tag of an item. So let's see how to do that. We have a formula for that as well. This would be number 3 or number 4. Okay, so percent, as you know, is, give me an example of a percent, any random percent, just anything.
27%.
All right, 27%. 27%. What do we exactly mean by 27%?
27 over 100 as a fraction.
That's right, as a fraction. 20 over 100. So percent literally means per 100 in French. Percent, pourcent, just means per 100. In French, I think it's spelled like this, pourcent. Okay, pourcent, 400. This is in French. So percent, I believe that's where the notation came from. So when you say 25%, it just means 27 per 100. Either as a fraction or as a ratio. You can also say 27 to 100. So a percent is just a specific or a special ratio where the second one of the values is 100. When you have the value here is 100, so that's just a ratio with a specific name called percent, means per 100 here. So that's all what we mean by percent. And to understand this more, when you say 27, for example, 27% of people missed class. That means if you have a class of 100 people, 27 of them missed the class. So 27% of students were absent. Instead of saying 27 out of 100 didn't show up, you can just say 27%. And we add this percentage sign next to it. This only works with per 100. If it's other than 100, you can't write this. We have to do some changes in the fraction. We have to normalize it, we say, before we can say it's a percent. We're going to look into that a little later. So that's all we know. That's what we mean by percent. Give me an example of a percent that's known that we use daily. Some actual percent that's relevant that we use daily. For example, the sales tax in New York. What is the percent?
8%, 8.7%.
Exactly, 8%. About 8% sales tax. New York state tax or sales tax. There's other taxes like property tax, income tax, but this one for sales tax. What does that mean? So for every 100 you spend shopping, you got to pay an extra $8. So 8% for every $100 spent. That money goes to the state or the government. This is a state tax, not a federal tax. There's also federal taxes and stuff. So this is where most of your paycheck goes. You see they slash off whatever, 30%, 40%, 50% of your income based on how much you make. In each state, it's different. At least for New York, it's 8%. So that's why in your receipt, after the total, you say, let's say you spent $200 shopping. This is total or subtotal, all the items together. Then you see in the receipt, it says tax. How much tax are you going to pay for 200? If that rate is 16, that's right. For each 100, you pay 8. We have 200, so that's 16. Then at the end of the receipt, you say total. This is a subtotal before tax. And then you say total at the end. And $200, you pay that extra money of the tax. So this adds up to your whatever you spent. But if it's a discount, when you have a store that has a discount, so instead of adding that percent to your purchase, it's actually taken away. It's minused from your subtotal. Let's look at an example. Let's say an item is on sale for 50% off. Item or whatever the sale something. Let's say you spent $300. Let's assume this includes the tax as well. So the subtotal is this. You will see in the receipt discount. So how much discount will you get if the discount amount is 50%? How much are you going to save from 300?
150.
That's right. 50% is half. This is basically like a very good sale, like you pay half price. So the discount is 150. And at the end, now instead of adding here, we added these two. But now you actually save the money because it's a discount. So if you subtract, you get 150 as a total. So this is the total. Okay, so the tax adds up to your total or subtotal of purchase, but the discount is in your favor. It actually saves you money. Okay, so that's how percents work. So some common percents. Some of them are easy to understand. Others might not be as friendly. Let's start with the common ones. So what is again 50% of something?
Is it half?
Is half, that's right. Any other common percents you know?
25.
25% is what in a word?
Is a quarter?
That's right. It's a quarter, just like a dollar. So a dollar has 4 coins, right? Each one is a quarter of a dollar. So the thing is, should be a quarter of a dollar, but we just say a quarter. A quarter of what? Quarter of a dollar, because it's 1/4. So 25% of something is a quarter, or 1 out of 4. Any other common percents?
80%.
80%, okay, that's good. Something close to 80%, which is a commonly used percent as well. A little less than 80%.
75. 75.
75. How many quarters is that?
3.
3.
This is 75%. 1, 2, 3, 75% of a quarter. So we say 3 quarters, or 3 out of 4. 3 out of a whole, which is 4. We have half, 3 quarters. We also have 1/10, or 10%. 10% of something just means 1/10. So if you have, I don't know, if you have 10 items, whatever it might be, and he said, give me 10% of that, means you're going to give me 1 out of 10, 1 out of each 10. So 1/10. Or 1 out of 10. If, let's say, if I wanted to, what is 100% in a word?
The whole number?
Try it, the whole or everything. They said, give me half, give me 50% of something you have, that means half. Give me a quarter, 25%. But he said, give me 100% of everything. That's basically means give me everything.
Free. Everything for free.
Pretty much, yes. Or as one student put it in the previous class, he said that's a robbery. When you say, give me all your money, give me 100%,
Yeah.
that's basically a robbery. So 10%, 100% is all or a whole. Or free, as you said, at a store. Basically, if it's 50%,
The discount.
yeah, if it's a discount, 50% this and that. If it's 100%, you would just write free instead of writing 100%. Discount, you say, oh, it's free, just take it. These are the most commonly used ones, and they're easy to understand. We can do them easily. What's half of this? What's third of that? Also, the third is 33%. 33% is also a commonly used one. It's third. Or 1 out of 3. But sometimes they're not always this simple. They're not always this convenient. Percent's going to be like 17%. What is 17% of something? Or 11.8% of something? Or 107% of something? That's why we need a formula for this. We need a formula, just like we did earlier with the ratios cross multiplication. We need a reliable formula that we can use regardless of how convenient or how complex the percent might look. So to do so, we have this formula. So the percent is always percent as we saw here, it's always something out of something. 27% is this over this. So we have a whole here. That's, we said here, the whole. Then we have a portion, a little bit out of that whole. So give me either half of it, third of it, or all of it. So the bottom part is called the whole. And here we have that we call the portion. All these are portions except for this one is the whole. That's the main formula of percents, and this solves a lot of problems. All these problems basically will be solved based or using this formula. So when you say, as an example, when you say, for example, 17%, is basically 17 out of 100. Is the same what is equivalent to this. So we have the percent itself, the portion, and the whole. And every time you have a word problem involving percent, there's always one of these missing. You will have one, and you have one. Actually, you will have two and one missing. So you need at least one to find the other. You could be missing this one, this, or this. Just like we saw with the X here earlier. X could be here, or it might be up, it might be here. X could be anywhere. Same thing here with the percent. You might be missing the whole, the portion of the percent. So it's up to you to understand the problem and figure out where to put the X, either here, here, or here. Let's start with a simple example of these, and then see how to figure out these not so convenient percentages. So let's say, start with an easy problem. Let's say 50% of 6. So we can do this one without involving an equation. We can do it quickly in our heads. What is 50% of 6?
3.
That's right. 50% of something means half. Half of 6 is 3. That was quick and easy. So let's see how to actually do it using this formula. Once we know how to use the formula, we can apply it to any of this. What if I said what's, I don't know, 13% of 27? This might not be as easy, right? 13% of 27. It doesn't look like these easy, convenient ones, but We're gonna get this one in a moment. Let's first do this one. We already know the answer here, but let's see how to do it systematically using basically ratios and equations. Here's what you do. So every time you have a percentage problem again, there's gotta be one of these missing, either this, this, or this. First of all, if you have the percentage, write it down first as a fraction. So the percentage as a fraction. So the percent here, 50% is 50 over 100. That's the first part. If you have it, write it as a fraction first. Then you write an equal sign. Now we just need to figure out what goes here and here. We said the whole goes here. Usually, not always, but usually the larger number goes here. And the portion, or the smaller numbers, goes at the top. So when you said 50% of 6, is 6 the whole or the portion?
6 is a whole number.
That's right, that's the whole, because that's the whole piece. We wanted 50% of it, so we want half of it, about this much. So this whole thing is 6. We wanted half of it, so that's the whole, that's the large number. And what we're looking for, let's say we don't know this yet. Let's assume we don't know it's 3 yet, so we put the x here. So 50%, write it first as a fraction. Then this is the whole, put it here. So we're looking for just half of 6. Half of 6. This is basically the equation. What do you do now to solve for x?
Cross multiplication.
Exactly. So we're going to cross multiply. So 100 times x. Then 50 times 6. And 50 times 6. This is 100x. This says 5 times 6 is 30. Then add a 0 to it, 300. And then to get the x, divide by 100. Divide by 100. So x is, what's 300 divided by 100?
3.
3. If we cancel these two zeros, 3 over 1 is 3. That's the answer we talked about earlier. It was easy because it was convenient, just half, no problem. So this is the way you do it. Turn whatever percentage problem into two fractions, an equation. Make sure you know where to put the x based on the wording of the question, okay? This could be worded differently, so we have to be careful with the wording of the question to find the number. Now let's do this quite complex one, not as convenient. So what do you do first? So we're looking for 13% of 27. What's the...
Professor, before you keep going, I have a question.
Mm-hmm.
The one you just did, you put 100 x over 100, and then you did 300 over 100. So if it's two numbers, it's a 3 and a 1. Well, we end up with only a 3 on it. I know that's the answer because we did it previously, but I need to understand why we don't just do 3 minus 1, for example. Because there's two numbers. Because like I said, it's 300 over 100. That's right. 300. Are you talking about this division, right? Yeah, that one right there. Yeah. So 300 divided by 100. Usually, if you have zeros, you can cancel those out. You cancel 2 zeros. Right. You have 3 over 1, not minus 1, because we divided. Right. We divided here. So 3 divided by 1 is 1. Only because it was easy here. But if you have something else, like you end up with a division like this here instead, then you have to do the division on the side and find out. This is probably 5 point something. Okay, is that what your question is? Yeah. Okay, so we divided both sides by 100. You can always do it your way, okay? This is a kind of shortcut, but you can always do it the regular way on the side. Okay, got it. Thank you. So let's go back to our example. So 13% of 27. Let's set this up. We need 2 fractions. One of them has x. So how do you set up this equation again?
30% of 30 over 100.
That's right. Always start with the percent. If you have it, immediately write it as a fraction. Equal sign, and then you'll have to figure out where to put the other number. This is the whole again, this is the portion. So what is 27? Is it the portion, the whole, or the portion?
It's a whole number.
The whole number, 13% of 27. Again, if this was 27, that's the whole 27. We only want a portion of it, a small piece, 13%, probably about this much, 13%. That's what we're looking for. If this whole thing is 27, how much will this cost? Or let's say this whole, whatever this is, piece of cloth or fabric, this whole thing costs $27. Only want to buy this piece, how much will it cost me? It's only 13%. How much money would that be? That's one way to look at it. So the whole goes here, and X goes here again. Now we're gonna multiply. So again, 100 times X. 13 times 27 times, what's 13 times 27? So 100x, 13 times 27 is?
351.
That's right. So usually you would do these multiplications. For the sake of time, we'll do it. X here. Now we're going to divide both by 100. Divide both by 100. Because we want to cancel this 100. So we're going to divide both sides. So we end up with X. And then when you divide by 100, as we saw before when we did divisions of fractions and multiplications, just going to move the decimal twice to the left. The decimal is initially here, it's invisible, so we're going to move it twice to the left. So this will be 3.21. And that's basically X, or 13% of 27. As we said, it's a small portion. This whole thing was 27. Small portion of it is 3. Again, if this was a piece of something and you want to buy, and the whole thing costs $27, if you want to buy only this piece, it will cost you about $3.21. As an example.
Sir, you wrote 321?
Yes, that's what you said it was, right?
No, I said 351.
51, okay. So this will be 5 here. And 5 here. Okay, so whatever the numbers might be, so you just move this twice. When you divide a number by 100, move the decimal to the left twice, and you get your answer. Now let's see another way of asking this a question like this. So let's say 2 is 40% of actually, let me use 50% instead. So 2 is 50% of what number? Again,
Oh, 4.
That's right. This is an easy one and a convenient one. So 2 is 50% of what number? That means there's a number, a larger number. When we take half of it or 50% of it, we get 2. Obviously, that number is 4. But let's see how to do that with the equations, because it's not always this convenient. Imagine if you have, I don't know, 19 here and 11% or 17%. We'll do that after this one. So if you have 19 is 7% of what number? So for this one, we can figure out easily. So 2 is 50% of what number? So this is basically the whole number. So we know that that number is 4 because 50% of 4 is 2. But let's put that into an equation and see how to get this 4 using equation. And later, we're going to reuse the same method to figure this out. Instead of 2 on 50, we're going to do 19 and 17. Okay, how do you set up the equation again? What's the first fraction?
19 over 100.
For this one, we're going to do this. We'll go back to this one later. So just do
Okay.
So I'm going to start with the percent. If you have it, always write it down. So it's 50 over 100. And then the other part, portion and whole. So this time, what does 2 represent? Is it the whole or the portion?
It's a portion.
The portion.
Exactly. So 2 is the portion. It's a smaller number. So this time we're missing the whole. We're missing this whole. So we're going to put
X.
That's right. X goes here instead of here. The rest is simple. Do the same, then cross multiply. Always start with the multiplication of the x first. So 50x equals what?
200.
That's right. 50x equals 100 times 2, 200. What do you do next?
Divide 200 by 50.
That's right. And divide by 50 both sides. Cancel that 50. We want that by itself. Then again, cancel 1, 0 against 1, 0. Now we have 20 divided by 5, which is
4.
And this is the 4 we talked about earlier that we figured out mentally because it was easy with this percent. Okay, now let's see.
I get it now. I get it now.
All right, let's do another example now with not so friendly percents and numbers. So 19 is what percent, or is 50%? Not 50%, but 19 is 17% of what number? Same way, what is the first fraction?
70% over 100.
Right, always start with a percent. If you know it, just write it first. And then with the
19 over x.
That's right. Again, 19. Just the same question. So 19 is the portion over the x. Then cross multiply and solve. So 100x, or start with the multiplication of the x. 17x equals 100 or 1900. Because we times these, then divide by 17. Divide by 17. What's 1900 divided by 17? Or B?
3.2.
It's going to be way more than that.
111.
111 makes more sense. 111. Evenly.
0.7. 0.7.
Okay. All right, so see, all these numbers are a little inconvenient.
Oh, I'm sorry, I got it. I did it wrong. Okay. All right. I know where I got it. I know where I made the mistake.
All right, so please always this equation here. Just again, understand your question first to figure out where to put the x. Here's another case. This one is this. So 2 is what percent of, well, let's say 3 here. 3 is what percent of 6? I think you could probably figure this one quickly. If not, we're gonna use the formula again. So 3 is what percent of 6? But how much, what percent, how much does 3 represent from 6?
50%.
That's right, it's half. So 3 is what percent of, notice here, this time we don't have the percent. We don't know it. This whole time we had it. This whole time it was given, we just wrote it on the left side. But sometimes the percent itself is missing. So back to this, sometimes you don't have this. So far, we only worked with these when this one was missing X here or here, but sometimes the percent itself is missing, but we have the numbers. So when you see what percent, that means you're missing percent. So we don't know what to put here. So where does the X go? So we know, when we know the percent, we put it here, but if you don't know it, so it's gonna-
On top. The X goes on top.
Exactly, it would be X over 100. I don't know that percent. We'll go here, over 100.
Yeah. Over 100.
This percent is unknown. And of course, we should have the other ones. We just have to figure out which one goes at the top, which one goes at the bottom. So what's the other fraction based on the numbers?
3 over 6, because 3 is a portion and 6 is a whole number.
Exactly. 3 is a portion of 6. And the rest, just cross multiplying, 6x and 300. If you divide by 6, divide by 6. So cancel these. What's 30 divided by 6? Just
50.
right. 30 by itself divided by 6 is 5. Is 5, and then you add this 0. So 30 by itself divided by 6 is 5. Then we bring down the other 0. Or if you want to do it the other way, you can do the regular division, that's fine. So if you can't see the shortcuts, you can always do the regular divisions like this, and you'll find that it's 50 here. Okay, so that's basically you find you can solve any percentage problem based on this formula and based on the word and the wording of the problem. So you need to understand the problem very well, understand what's missing, and put the X in the right place. You'll always have the other two. You'll be missing one of these, and you'll have the other two. Just figure out what to put and where correctly. Okay, so that's one way to do it. So if it's something like this, so next time you see on a window, for example, 50 or 25 or 75, this is something you can do quickly without having to do the formula. But if you have to if the percentage is not very clear or not as convenient, you can do this quickly, do a lot of math on the side, and you can find out your exact numbers and percents. Okay, any questions so far? Everybody?
Oh, thank you.
No
I'm gonna
questions.
go over this video though.
Say that again?
I'm gonna go over this video.
Yeah, definitely.
I mean,
yeah.
you know, I have to.
I suggest everybody go over this again. We're lucky we have this is being recorded and everything, so we can rewatch it. Unlike in a physical class, once the lecture is gone, I mean, it's gone, unless there is a video camera in the room, but most of the time we didn't have any recording device, so but now, conveniently, we rewatch this whenever we want. I believe that covers it up for today's class. You'll see plenty of this in the homework. A lot of questions like this, very similar.
Okay, good. Okay.
Get stuck,
Right.
get confused, just go back to the video again, rewatch it, rewatch the specific problem, and you should figure out all your percents. The more you work
Got
with
it.
class, the more familiar you'll get with them. And trust me, you'll get to the point where you can do this quicker in your head, even with the inconvenient percents. With experience, you can do that in your head too in seconds using approximations and stuff, but that would require some practice. So practice makes perfect.
All right. Got it.
Thank you very much, sir.
All right, so
Thank you, Professor.
just to recap, so that's the lesson, that's the lecture. I'm going to post it. I'll post your quiz grades sometime soon, and then work on the review sheet for the midterm. It's on Blackboard in the homework folder. So try to do all those questions. If something is not clear, try to find an example from the lectures. I believe we covered everything. If not, just write it down. We're gonna have a review session before the midterm. Midterm again is the following week, not next week, but the following week. The exact date is on Blackboard along with the review sheet. Any questions for the day before we dismiss?
No questions.
No, thank you.
Okay, Jennifer,